Okay, I think we are on. Good evening, everyone. Welcome to Death Valley on a nice, warm but calm and clear late summer evening. We've had a week of a bit of cool off, a bit of fall weather where the humidity's let up, and so some astronomy is happening again. It's been a long, hot summer, but we had a really good week, and tonight it's just looking like some outstanding weather. So tonight we're going to see a lot of really cool, fun stuff, and some of the nicest things that are in the summer sky are going to be up for tonight, and so I hope you do enjoy it. Let me turn this down. So, okay, good. All right. Okay, so let me first start off with how I should start, which is with my setup, and show you what it is that I use. And let's turn this test pattern off so I can do this. Okay, and then this is still in the wrong place. Okay, so no, it still keeps trying to maximize. Wow, I cannot make this thing move where I want it to move. Okay, drop it right there. Stay there. Okay, so here is my setup. It is a 6-inch f4 imaging Newtonian that I'm using a coma corrector in that is actually reduces it to f3, so it makes it a little bit faster and better for astronomy, photography specifically. And it's on this AM5 strain wave mount and my spare no expense cinder block pier. And yeah, so this is what's basically the camera's stuck in up top here, and so this reflector telescope is what's bringing us all the images tonight. And I'm sitting behind this computer, behind this table, and talking to you now. So this is what's going to be used tonight to bring you all of those images. So let's start off with cat's paw, which is it's a really nice little nebula in the extreme southern sky. As you can hear, got a little bit of a breeze tonight, but it shouldn't amount to a whole lot, or at least it's not supposed to. We'll see what happens. Okay. Wind is always a crapshoot out here. The last couple of nights it's been really calm, and this evening it's been really calm until right now, when it's just decided to pick up a little bit. Okay, so let's get this started. Oops, and that's not going to work because I don't have my guider started yet. Okay, get this going. Connect everybody there. Go away. Get that going. Alright, that's working. Now we'll get this going, and this should work a lot better. Okay, and I've also got to resize these windows because you cannot see why are you doing that? Okay. You cannot see all this. Alright, I have to shrink this up somewhere in there. Alright, got to get all these going. I think that's right. Gonna need to reset all of this and reset this. should have our first sub coming in right now. It looks like I got it pretty close. Alright, get those colors balanced. No, too soon. Alright, get this moved in over here. And this moved in over here. Okay, and there it is down here. Not sure why. Not sure why it's so off center. Well, okay, let's take a look and see what's going on here. 183, 6, okay. Yeah, so it's in the middle enough. So there's more of it in here. We're just gonna have to. Okay, gotta get this window sized up so that you guys can see more of it. And the guider is constantly complaining that it can't find stars, even though it's guiding on stars. Alright, let's try it again, see if it's happier now. Stop and restart, see if it's happy now. Alright, we can see the start of the nebula in there. As soon as I can get all this stuff started and running smoothly, we'll go on to Wikipedia and see what it has to say about that. Okay, I think we are that's pretty much well sized there. I think that's about the right size on the window. So let's now take Stellarium and bring it in so that we can see it. Hello Marissa and hi Pamal. Alright, let's put this up here. I think all these windows are resized. Alright, so now you guys can now see that. Ooh, look at that, nice. If I can't get rid of that. Come on. Oh, it's not responding. Okay, good. Got rid of it. Well, we lost 2 subs in the process, but at least it did get rid of it. Got rid of 1 satellite trail. We definitely have a lot of satellite trails these days. Okay. So what is the NGC number on this? That's probably NGC 6334. Alright. Let's Wikipedia NGC 6334 Mission Nebula in Scorpius, also known as the Cat's Paw, is an emission nebula and a star-forming region located in Scorpius. This is in the very low southern sky, and so those of you in the northern half of the country probably can't see this at all. It's really low in the south, and so it's very low in Scorpius. It's located in John Herschel discovered it in 1837. It's located in the Carina-Sagittarius arm of the Milky Way at a distance of approximately 5,500 light years. It's a filamentary cloud that is approximately 320 light years across. So this is what's known as an emission nebula. It is basically stellar gas and dust that is being irradiated by the stars that are around it and inside it, because it is a stellar formation area. And so this is a stellar nursery, basically, where stars are born. And the stars that are inside it and around it will actually irradiate the hydrogen in the nebula, and it causes it to glow red. And so we see it as a red-looking nebula. Hi, Adrian and Isaiah. Welcome. So I'm broadcasting to you from just a little bit south of Death Valley in the eastern California desert, basically the eastern Mojave Desert, and bringing you some astronomy and some cool objects from the desert. So as I was saying, this is the Cat's Paw Emission Nebula, and it is basically it's a cloud of gas and dust, which is what nebulae are. And most nebulae, not all, but most nebulae is eventually forms stars. Gas eventually coalesces and continues to kind of like coalesces and clumps together, which creates a little bit of gravity, which clumps it together a little more and brings a little more in, which creates more gravity, and more gases just start collapsing and collapsing on this growing mass. And after that happens for a long enough period of time, and a huge enough mass is collected, then eventually the pressure is sufficient to ignite the star, and a new star is born. So these lots of emissions, lots of nebulae create new stars, and this the Cat's Paw Nebula is definitely one such star-forming region in our sky. Guiding is finally starting to settle down a little bit. And I will put up here in the target name, I will put the name of what we are. If I can type, I will put the name of things up here. Cat's Paw. It's not a very big box, but I will try to keep it populated with what we're seeing. And in Stellarium, if any of you have Stellarium, this is a free open source piece of software called Stellarium, freely to download it, and it has the whole sky in it. And so this is called the Cat's Paw Nebula or the Bear Claw Nebula, and then it's in a number of catalogs. The NGC catalog, the New General Catalog, or NGC catalog, has it as object number 6334, and the Sharpless catalog, which is SH2, has it as object number 8. There's a number of different catalogs, many different catalogs, that different stellar phenomena are cataloged in. Some catalogs are dedicated to types of things like nebulas or galaxies or stars, and other ones are just the brighter things in the sky. But there's a number of different catalogs that have been created over the centuries, really, to keep track of the virtually countless number of things in the sky that our astronomers like observing. And tonight we're going to see some of the nicer stuff, at least nicer stuff in the southern sky. So I generally take about 10 or 15 minutes or so on each object, and let the images build. Tonight we will be taking 60-second sub-exposures. So basically my camera that's in my scope takes, I can adjust it to take however long exposures I want, and we're going to take about 60-second exposures. And basically this software, which is called SharpCap, that we're looking at right here, stacks those 60-second images. It takes the first one, and then takes the second one, and using the background stars aligns them and stacks it over the top of the first one, which increases the signal to noise ratio, giving you a cleaner, brighter, more contrasty picture. And every subsequent sub-exposure that comes in just keeps getting stacked on and stacked on and stacked on, which makes a brighter and more color saturated and more contrasty image. So as time goes on, the image will get better. Obviously, if we sat here for hours on the same object, it would continue to get nicer and nicer and nicer, but then we wouldn't get to see more than one object. So this allows us, basically the software allows us to control the camera and stack a bunch of sub-exposures, which gives us a much brighter object than we would see with just one exposure. It would be equivalent to one really long exposure. If I take 15 1-minute exposures, it would be somewhat equivalent to a single 15-minute exposure, but obviously we don't get to see the object as we're going along, and it requires much more sophisticated equipment to hold an exposure for that long. You know, for our amateur astronomy equipment, we don't have that really expensive, big, heavy equipment that they have in professional observatories. So keeping the exposures to reasonable time lengths, a minute or 2 or 3. I go as long as 5 minutes. But it just makes the job a lot easier on the hardware. So tonight we're going to see a bunch of nebulae, but we're also going to look at some star clusters as well. But in this area, we're basically going to stick between the constellations of Sagittarius and Scorpius, which is in the very southern sky. Kind of right now it's southern, pretty much dead southern, but it's going to continue to rotate west as the evening goes along. And so we will continue to track those objects. But that's where we're going to be tonight, in the low southern sky between Sagittarius and Scorpius. That's where all these objects live. Okay, and I realize I haven't turned the background music on. I want to turn that on. And tonight we will see all 3 types of nebulae, and I'll talk more about those as we see the other kinds. But there are basically 3 types of nebulae, and we'll get to see all of them tonight. Thankfully, that one little breeze that picked up there for a few minutes has stopped, and we're back to being just a nice, beautiful, calm night, which is a good thing. So we'll finish this one last sub-exposure to be at 15 minutes. and then we'll move on to the next one. Alright, there's 15 right there. Okay, so we will now head up and see what our next object is. While it's doing that, we'll take a look here just above the cat's paw. So here, I can show you in the planetarium actually where we are. So there is Sagittarius right there. And Scorpius is over here. The little scorpion tail with the stinger that curves around and comes up, and his head is up here with two claws and the head up here. And so we're going to pretty much stay in between, right in this area in here tonight. And so we just did the cat's paw, and now we're going to go up to here and do, well, I call it the lobster. It's also called War and Peace. I'm going to move it over just a little bit. I'll get the number back up here in a minute. I'm going to get it a little bit centered so that we see a little more of the object. Yeah, sketching is a really good thing to do when you do astronomy. It makes you see more. It makes you pay attention, and see. You actually end up seeing more details when you do sketch as opposed to just observing. So it's a very good thing to do when you're doing astronomy. Lobster Nebula, NGC 6357. Lobster or War and Peace, but I like calling it the Lobster. Lobster Nebula. Okay. First 60-second sub-exposure will come in. And I like this for the bright, shiny blue and yellow stars that kind of come through it. I think that's pretty neat. Okay, let's balance those colors out a little bit. And move this over just a little bit. And we'll let that come in. Alright, NGC 6357 is a diffuse nebula in the constellation Scorpius. It contains many protostars shielded by dark disks of gas and young stars wrapped in expanding cocoons or expanding gases surrounding these small stars. It's also known as the Lobster Nebula. This nebula was given the name War and Peace by the mid-course space experiment scientists because of its appearance, which in infrared images The bright western part resembles a dove, while the eastern part looks like a skull. It is located, again, about 5,500 light years away from Earth, so pretty much the same distance as the cat's paw was. This nebula includes the open cluster Pismis 24, which is home to several massive stars. One of the brightest stars in the cluster, Pismis 24-1, was thought possibly to be the most massive on record, approaching 300 solar masses, until it was discovered to be a multiple system of at least 3 stars. Component stars would still remain nearly 100 times the size of our Sun, making them among the more massive stars on record. Well, so some of these stars are really, really big. Yeah, I like writing the music. It provides the ambiance appropriate to, I think, astronomy. Besides, then I don't have to keep yammering all the time. You guys can listen to something better than my voice. Speaking of which, time for a drink. So I'm trying to restarted the stack with a little bit more gain on the camera. We'll see if that helps. See things a little bit better. These first two objects that we picked, that I picked, are fairly dim objects. They're not, don't have a lot of brightness to them, but they're still really nice to look at. They are better to use with a filter, and the filter basically, it doesn't make the nebula brighter, it makes everything else darker. So the overall result is it brings the nebula forward in brightness quite a bit. And so for these dim emission objects, it's actually a better way to go. But these are bright enough where you can see most of what's going on, even without a filter. And the next few objects we're going to do are going to be a lot brighter than this. And these objects are also very low in the sky. I think this object is only about 15 degrees up. Yeah, it's 15 degrees above my horizon, so pretty low in the sky. And it being that low does not help with the contrast much either, because you're shooting through a thicker part of the atmosphere when you go low in the sky. Which is why when you look straight up at night, the background sky seems a little bit darker, a little bit blacker, because you're looking through the one thickness of atmosphere. But when you look down near the horizon, you're looking at it at an angle, so you're seeing through a lot more than one thickness of atmosphere. Which is why the sun sets and rises red, and the moon, same thing. Turns to yellow and red because it's more of the light refracting through more atmosphere. So when we're taking imagery low on the horizon, it tends to be a bit dimmer and a bit less contrasty. But I've started with the lowest stuff in the sky tonight, and we'll be working our way upwards as we go. glad you like the music. It's by somebody named Jesse Gallagher, who basically creates this music and allows people who create live streams on YouTube to use it for free. So he creates some nice sounding stuff. So I'm happy to use it on my broadcasts. It suits my broadcasts pretty well for the type of stuff that we do. Looking at nebulae is like looking at clouds. You know, you can put a whole line of people lying on their backs in the park looking at clouds overhead, and everybody's going to see a different shape. So some people can see the lobster, some people cannot. It's the other thing is that most of these objects were named quite a number of decades ago, if not centuries ago, when their astronomy equipment could not hope to see anywhere near as much as we can see tonight just with my 60-second exposures with my camera and my little scope. And so what they were seeing when they named these things is a fraction of what we see today. So sometimes they don't make a lot of sense what they named them to what we can see with our modern cameras using long exposures, because we see a lot more than they could back then. And so I don't know, some of them should be renamed. But most of them actually still look like what they were, look like what they saw all those years ago when they first discovered them. What did we say? Was this John Herschel who discovered this? No, it was John Herschel who discovered the cat's paw. But I don't think temperature mass. They don't really say who discovered this one, the lobster or War and Peace. They don't really say. Hello, Red Angel. We'll do just a couple more minutes on the lobster here, and we'll then move to our next object. What is our next object going to be? We could probably move to a star cluster. You guys see right next door is M7. Object number 7 on the Messier list. So we can take a look at that. M62 is also pretty close by. Maybe I could do M62. It's right there as well, although it's further west, and I'm getting close to. Yeah, I think we'll do M7. Ptolemy's cluster. We'll do that one next, because I'm starting to get, as the sky rotates to the west, I'm starting to get a little bit closer to a building, and we're going to start, objects are going to start disappearing behind it, so still yeah, M62 is a little bit too low yet. Alright, there's 15 of those. Maybe if some of you can see the lobster. Some of you can't, but well, sometimes you have to use a little imagination. Welcome, Maria. Okay, let's go do a open star cluster next. So something that will definitely be a bit brighter, which reminds me I want to go back to my lower gain setting, which will be better for the camera, better for our images now that we're going to start doing some brighter stuff. Okay, let's go over to M7, Ptolemy's cluster. Ptolemy's cluster is something that is a great binocular target. It is right, so there is Sagittarius, the teapot on its side, the top of the teapot there, the handle of the teapot, and then the spout of the teapot. So that's Sagittarius there. And Scorpius is over here, curves around, it comes out with this little stinger there. And this is right between the two of them. You can actually, if you go outside, you can see it naked eye if you have fairly dark skies. Not everybody has very dark skies, but okay. Let's make sure we have, there's, make sure we're centered on it. Yeah, we're good enough. Okay. Alright, let's take some snaps of a star cluster. Now this is so bright that we're actually going to reduce the time. I've been taking 60-second exposures on the fairly faint nebulae that we've been doing thus far. This is going to be, because stars are very bright, we will be doing, I'm going to reduce it to 15 seconds. There we go. So we see some patches of dark dust here and a dense star field, and then this really nice cluster right here, which is M7, or Ptolemy's cluster. Which I'll write up here. Because Ptolemy is the first one to the first one of note to discover it. Yeah, Red Angel, the Scorpion constellation is a very cool constellation. It's also one of the oldest constellations. It's literally several thousand years people have recognized Scorpius as a scorpion, and so it has been so named for thousands of years. It's one of the oldest named constellations that there is. So yeah, it is a very cool constellation. But so now we're looking at M7 here, and you can see as we can start to accumulate more sub-exposures, we're starting to see some dark, dusty patches covering the very bright star fields that are in here. Because when you're looking at this part of the sky, I'll go back to the planetarium here for a second. You can see the Milky Way coming in here. This part of the sky, right here between Sagittarius and Scorpius, is the core of our Milky Way galaxy in here. And so the star fields in here are really, really thick and dense, and you get to kind of see that here. See, it looks like we have star fields that there are some thin areas of the stars, but it's not that the stars are getting thinner here, it's that these are areas of dark dust and gases that just absorb or block the light. And so these are just very, very dense star fields that exist near the core of our galaxy, the Milky Way. And some dark patches of dust and the gases and the light-absorbing gases and things actually block some of the stars and some of the starlight, and so that's why you're seeing all this interesting texture in here. But this is M7, or the Ptolemy's cluster. It's easily detectable with the naked eye. Yeah, if you have, not from the city it isn't, but you know, if you have fairly dark skies. Southernmost, it is the southernmost Messier object, and the Messier objects, I should tell you about that. This is M7, or Messier 7, the seventh object in Charles Messier's catalog that he created about 100 years ago, when he was a comet hunter, and he would look in the sky every time he could to try and find comets, and he kept finding these other objects. And so, you know, these bright objects that were cool, but they were not comets, and so he didn't want to keep getting distracted by them. So he created a catalog of these objects that were not comets, so that he wouldn't waste time, you know, focusing on things that he was not after, which was comet chasing. And the end result of the Messier catalog, as it has become known, is that it has 110 of the biggest, brightest, and most spectacular objects that are in the sky. The Messier catalog is typically what most amateur astronomers start with as their first objects when they view things, because it is just a fabulous catalog. And it's only 110 objects, but they are the most beautiful, brightest stuff that's out there, like this star cluster, and like some of the things we're going to see here shortly. And so M7, or Messier 7, the Ptolemy's cluster here, is the seventh object that he put in his catalog, and as the Wikipedia says here, it's the southernmost object from his catalog. M7 has been known since antiquity. It was first recorded by the 2nd century Greek-Roman astronomer Ptolemy, who described it as a nebula in 130 A.D. Italian astronomer Giovanni Battista Hodierna observed it sometime around 1653 or 4, and counted 30 stars in it. In 1764, 110 years later, French astronomer Charles Messier catalogued it as the seventh object in his catalog. And English astronomer John Herschel described it as a coarsely scattered cluster of stars. Telescope observations reveal about 80 stars within a field of view of 1.3 degrees. At the cluster's estimated distance of 980 light years, so it's just under 1,000 light years away, which is fairly close to us. The cluster is about 25 light years across. The tidal radius of the cluster, blah blah blah, has about a combined mass of 735 times the mass of the Sun. So all the stars add up to about 735 times what our Sun weighs, the mass of our Sun. And it's about 200 million years old, which in terms of stars is very young. So it's just under 1,000 light years away, and you see we're starting to get some of that nice texture in there. We'll just do another minute or so on this. Don't need to do nearly as much time on the star clusters as the fainter objects. But it is a pretty cluster, and it's great for if you're in a fairly dark sky place, you can see it naked eye. But if you have binoculars, it looks really nice. It's a really great binocular target. So, summer camping and in a dark spot is it's one of the nice things to look at when you're sweeping the sky with binoculars. Okay, let's continue working our way up here. M6 is another little star cluster. I think actually this is the butterfly cluster, so this is a cool little cluster. We'll do that one next. Go. Definitely got a little breeze kicking up again. Sorry, we've got a pretty good wind that just picked up here, which is driving the telescope crazy. So until it calms down, the images are going to be a little bit wacky. Happens out here in the desert, suddenly you get wind bursts. Okay, that little burst of wind finally died down, so I can turn my microphone back on again. Alright, so this is going to be, we're on Messier 6 right now, the butterfly cluster. If you look at this through binoculars, it actually looks like a butterfly. What we're seeing here, I'm actually going to reset this because it's a bit smeared because of the wind. But it actually does look like a little butterfly if you're looking at it with binoculars. There we go. Finally got some fairly tight stars in there. So yeah, this is maybe if I can unstretch it a bit, we might be able to see, make it a bit darker. Yeah, it's really hard to see. The camera is so sensitive; it picks up so many more stars than you can see if you're just looking at it with the binoculars. But you can see kind of the head there, and the wing there, and another wing there. It actually looks much better through binoculars than it does with the camera. It's an open cluster. Okay, so what Wikipedia has to say about it. It was discovered by Giovanni Battista Hodierna in 1654. However, Robert Burnham says that Ptolemy, who has discovered the cluster that we were just looking at, probably observed this as well back in the 2nd century AD. Well, the wind is definitely playing more of a part here tonight than I was hoping it would. Hopefully I'll be able to continue. But right now, it's not looking great. Wikipedia also states that the distance of this cluster is about 1,600 light years away and is approximately 12 light years across. So not a real big one and not real far away. And is about 120 stars, they think. Or at least 120 stars that we've identified so far. In any event, I think we don't need to spend a lot of time on that. Let's go to our next object, which is going to be the Lagoon Nebula. So this one's going to go back to the nebulas again after doing a couple of star clusters. We'll go back to doing some nebulas. Hopefully the wind will be enough that I can continue, but it's not being nice right now. Okay, let me make sure. Yeah, that should be about right. Okay. So this is going to be Messier 8, the 8th object in Charles Messier's catalog, called the Lagoon Nebula. And unlike the two nebulas we've already been looking at, this one's going to be nice and big and bright. Boy, this wind is being absolutely merciless. Yeah, unfortunately with this wind I'm not going to be able to get very good images. It's all kind of smearing because the wind is so strong. We'll give it a couple of more minutes, but if the wind doesn't let up I'm going to have to pack it in, unfortunately. But this is the Lagoon Nebula, or Messier 8, the 8th object of Charles Messier's catalog. It is a interstellar cloud of gas and dust, and it is a star-forming nebula. It's another great binocular target. You can actually see it naked eye from fairly dark skies, but it's a great binocular target as well. It's large and bright. And it's about 5,000 light years away from Earth. So, and it's a little over 100 light years across. One of the things you might be able to see in this nebula are these dark patches, and these are dark areas of protostar material. Basically, they're just dark, dense areas of dust and gas, and they're actually called Bok globules is the name of them, and you can see there's a number of them around. Usually they're a lot sharper than this, but with this wind I'm having tonight, everything is kind of smearing a little bit. If I zoom in a little, you can see them a little bit better. But yeah, these are areas of dark protostellar matter, basically, because this is a star-forming region. So there's a lot of young, hot stars in here as well. Well, thanks, Pamal. The night certainly started off calm, but it has kicked up its heels here in the last 15 or 20 minutes or so. But even though the objects won't be as clean and sharp as they normally are, and the stars will be a bit smeared, we can still see generally what's going on. And in this one, the dark red areas are again hydrogen, which is emission nebula, and the lighter areas, the whiter light pink areas, are more oxygen. That's showing up there as a different color, and so that's why it's got sort of a pink carnation-y color in the middle, and then the deeper red to the outsides, and almost like a brown color down in here. And now the wind calms down again for a minute. I wish it would just stay calm down, but yeah, Red Angel, the Ptolemy's cluster was located between Sagittarius and Scorpius, so right in the deep southern sky. So this is right in the very south. This is my horizon, and that's dead due south there, southwest there. So in the southwestern sky right now, you can see Sagittarius is there, the teapot, the handle, and the top of the teapot there, the teapot itself, and then the spout there. So this is in the southern sky, and then Scorpius is here with the curved body and the tail and the two stars making the stinger for the scorpion. Ptolemy's cluster is right there. It's sort of if you go out and look at a fairly dark sky, you can see it's a fuzzy spot right between the two constellations in the southwestern sky. So that's where Ptolemy's is. So there's Lagoon Nebula. I'm not going to spend a lot more time on this because the breeze is blowing things around too much for it to be a terribly great image anyway. But we're going to go to do at least one more here, and this one is a really interesting one. This one is M20, and it's right above Lagoon Nebula. It's right here. It's called the Trifid, and it's a neat one because it has all three kinds of nebulosity in it, as we will see after we get the first sub-exposure in here. the Trifid Nebula. It's not only pretty, but it's also quite interesting. So the Trifid Nebula is a star-forming region in the Milky Way's Scutum Centaurus arm, so that arm of the Milky Way. It's discovered by Charles Messier in June of 1764. And the name Trifid means three-lobed, because the object is a unusual combination of open star clusters of stars and an emission nebula, a reflection nebula, and dark nebula. And actually we got a pretty decent first sub of this. But here it is, and the emission nebula part is similar to what we've been seeing already. The reddish, pinkish hydrogen, and then the whitish oxygen. And then this blue part is actually reflection nebula. So the emission nebula is, again, the gases and dust of the nebula are being irradiated by the stars, burning stars, and they actually fluoresce and emit their own light. So it actually lights them up. It makes them emit their own light through radiation. As opposed to reflection nebula, which is the blue part, the reflection nebula is actually reflecting the light of stars that are in and around the area. So it's not generating its own light, emitting its own light, it's reflecting the light of the stars that are around it and in it. And then the dark nebula is these dark little lanes in there. We can just kind of zoom in real quick. So these dark lanes in here are actually dark nebula. So it's not that the red part is not here, it's that it's being covered up by these dark nebula areas. And so this one nebula, the Trifid Nebula, has all three kinds of nebulae in it: emission, reflection, and then the dark nebulae as well. And that's actually what we were seeing when we looked at Ptolemy's cluster. Sort of the texture and the background star density was again the dark nebula. So it's dark interstellar gas and dust that either blocks or absorbs light, and it doesn't allow it to get to us here. And this is also a star cluster down here. I'll bring up the annotation so that we can kind of see. Yeah, so this is NGC 6531 is that star cluster down here. Thankfully the wind has let up again. Maybe it's moved on, hopefully. We can always hope. Okay, so as we were saying, its name means three-lobed. The object is an unusual combination of an open cluster of stars, emission, reflection, and dark nebulae. Viewed through a small telescope, it's bright and peculiar and is thus a perennial favorite of amateur astronomers, like all Messier objects. And this is the 20th item in Charles Messier's catalog. The the most massive star that is formed in this region, is about 20 times the size of our Sun. And this star is surrounded by a cluster of approximately 3,100 young stars. The Hubble Space Telescope did a study of the Trifid in 1997 using filters that isolate emissions, and the images were combined into a false color composite picture to suggest how the nebula might look to the eye. Close-up images show a dense cloud of gas and dust, which is a stellar nursery full of embryonic stars. This cloud is about 8 light-years away from the nebula's central star. Did it say how far away it was? No, I don't think it says it up there yet. Details and features, no. So I'm going to assume, oh yes, it's centered about 4,100 light-years from Earth. Okay, so it might be a little bit closer than Lagoon, which is interesting because it's so much smaller. Lagoon is really big. Oh, look at that, we got a satellite through there. I wonder if that just happened. Well, we'll find out. I'll click that, see if it gets rid of the satellite. Oh, it did, yay. Sometimes I miss it, and it's all I can do is get rid of the most recent one. Thankfully, we got it in time. So this is about 4,000 light-years away. And it's just a really pretty cluster. Really pretty nebula. And the star cluster down here, just a little bit of the dense star field of the Milky Way itself down here as well. So kind of get a little bit of everything in the image of M20, the Trifid Nebula. Write that up there. Trifid Nebula. I know what you mean, Marissa. I have a lot of favorites in here. There's just so many neat things to look at in this particular part of the sky that I would have a hard time saying which one is my absolute favorite. But in terms of colorfulness, this is just the red and the blue and the sharp dark lines in it. It really is one of the nicer ones. Although Lagoon is just so big and bright and beautiful that, but it's just one color. You know, you don't get that nice blue. This is such a nice contrast of colors that it's hard to beat. But yeah, I have a lot of favorites in here. No, Ray, you're not going to see these like this at the eyepiece. Everything's just going to be a faint gray fuzzy at the eyepiece. The human eye just is not sensitive enough to be able to see the colors and the brightness like this. So that's why we made cameras with sensitive sensors and the ability to hold the shutter open for long periods of time to collect a lot of light in each sub-exposure. And now we use software like this, SharpCap, that I'm using, where we stack a bunch of those exposures and make them even brighter again. So thanks to technology, we're able to see things, well, I mean, in our own backyards using amateur equipment like I have. We can see things that they couldn't see, the pros couldn't see even 20 years ago. So, you know, it's come a long way. But if you observe visually, you can't see colors like this. You can't see nearly as much detail or as much extended nebulosity. But there's still something about looking at it live that is very fulfilling, even though you can't see as much detail and color and whatnot. Looking at things live, just taking binoculars outside at night, on a dark night when the Milky Way is overhead, and just, you know, leaning back, even getting an inflatable, you know, pool dinghy or something under your back, and just sort of lying on the lawn, whatever, and just cruising the sky with your binoculars or a small telescope. It really is a very cool thing to do. So, visual astronomy is not dead, but it certainly can't do this. Yes, EAA has electronically assisted astronomy, or the use of electronics and cameras and things and computers to get images like this has definitely taken over, because you can see so much more. So yes, star parties 5 years ago used to be mostly visual observers and a few people who were doing imaging, and now those numbers have completely reversed. So These modern cameras of ours just see amazing things. They've come a long way. Well, we're just about to 15 minutes on this, and the wind continues to be calm, so it looks like we just had one about 30-minute burst of wind, and it has calmed back down again, so looks like I'll be able to keep going for a while. So next we're going to look at another interesting area that has some pretty dense star cloud area. We're going to look at sort of an edge of the Sagittarius star cloud. So there is the Trifid Nebula. Hope you enjoyed it. It is one of my favorites. So we're going to go to another little area in here. As we continue to climb up the sky. Now we're kind of right above the teapot of Sagittarius here. Kind of right above it on the Sagittarius star cloud. Right in here, there is, IC 1284, which is there. So we've got this nice little area of, I think actually we'll bring it a little bit further than that, piece of the Sagittarius star cloud, and then some more reflection and emission nebulosity. And we'll get to really look at a pretty dense area of star cloud as well. Good night, Marissa. Thanks for coming in. Oh, I see. I misunderstood. It's not Marissa that's going away. It's Bimal that's going away. Have a great night. Thanks for coming in, and I'll see you next time. I might even be doing another broadcast of, maybe this weekend if the weather holds. So we'll see what happens, or possibly later in the week. We'll see how my schedule and the weather hold up. But it looks like it's going to be fairly good. But thanks for coming. Alright, so first sub-exposure coming in here on this one little area. Yeah, I actually want to move this. I actually want to move this over here. And we're going to need to reset the guider because we moved things. Okay, let's take you, turn you off. I want to put this in the center of the image. You can see the dense star field here. And then we're going to areas of red and areas of blue. So we're going to see sort of a mixture of those things here. Okay. That clear? No, I clicked on it, it didn't do anything. Clear. Okay. Now we should have that object in the middle of our screen. Yeah, there we go. I'm gonna go get my light shroud. I think we're picking up some stray light here, which is what this brown streak is. Good night, Maria. Thank you for stopping by. Like I said, hopefully I'll be doing another one later in the week, but we'll see if the weather holds. Okay, let's clear this out. We should be getting a new sub. Well, it's still in there. I don't know what that is. Picking up a piece of light off something. I'm not sure what's going on there, but that's not normally supposed to be there. Oh well. I don't know what that is. Some sort of a light streak. You know, it could be a power line. I think we're shooting right through power lines. And so I think that is actually a power line wire that's being diffused into this broad looking thing. So I think, in fact, what I'm going to do is go off this, since this is going to just pretty much ruin this thing. I think what I'll do instead, so we'll go back down and do the Chinese dragon. because that wire is running right through the image, which is going to make it just look like crapola. Let me get down here. We're going to do this area in here. Okay. This is a really pretty area too. It's called the, some people call it the toes, some people call it the Chinese dragon. It's right next to the Lagoon Nebula. And it's a really pretty area, especially once we get a few sub-exposures pulled in. It's a really nice area. Well, this has the wires on the other side. Okay, well, it looks like we're just being plagued by wires. So, I think what I'll do is I'll just head up. Head up higher. It's a really pretty area too, but not with a big honking wire running right through it. So let's keep heading up here. And we'll do... where am I here? Yeah, we'll do... Omega. That should put us well above the wires. The Omega Nebula. The Omega or Swan Nebula. This one's also called the Lobster Nebula, or the Horseshoe, or the Checkmark. Anyway, it's the 17th item in Charles Messier's catalog of objects that were not comets. And it's above Sagittarius. Now we're going to have a satellite bombing through. But there it is. I'll show you where. So we are there. So Sagittarius is now down here. Scorpius is down here, well below. So we're starting to just continue heading up the sky, which is good because these objects are starting to get kind of low. It's called the Omega Nebula, or the Swan. Come on. Back you off just a little bit. So I should have color balanced you first. Get a little more red. Looks like we're going to have a slow moving satellite punching through here. Well, maybe it was headed the other direction. Well, I see a little bit of the tail of it heading out. That would be fine. M17 was discovered by Philippe Lois de Chazeau in 1745. Charles Messier catalogued it in 1764. It is by some of the richest star fields of the Milky Way, figuring in the northern two-thirds of Sagittarius. So again, this whole area in here is the center of the Milky Way. So all kind of, we're looking right at the core of the Milky Way here. And the reason we're not seeing a big, huge glowing thing here, because the center of our galaxy is pretty bright, is simply because there's a lot of stuff between us and the core of our galaxy. A lot of light absorbing and light blocking dust and gases and things. But still a very dense star field, still a lot of stars here. And just a really interesting area. Yeah, Ray asked about my script. Yes, I'm using sequencing. I'm using the sequencer in SharpCap, which allows me to set a sequence of settings for when I use one sequence to slew to new areas, where it increases the gain and cranks the display histogram and makes it so that it can find objects easier. And then once I get to the object, then I use a second sequence to reset all the settings optimal for taking the image. Going to the set exposure, in this case 60 seconds, setting the gain to what I want, in this case 53, etc., etc. And so, yeah, every time you slew to something versus take an image, you want a lot of settings to be different. You want the guider to be off for the slewing and on for the imaging, etc., etc. And so there's just a lot of steps. And so you can set up sequences and automate all of those steps for initiating either one of them. And so that's what I do. That's what you're seeing there when the screen kind of fills up with stuff, is that I'm running the sequence to initiate, in this case, imaging. And all of that is built right into SharpCap. You can build your own scripts to invoke whatever functionalities you want, set whatever settings you want, however you want them set. So it's a very powerful piece of SharpCap. Hey Greg, thanks for stopping in. Yeah, it's been mostly a good night. About half an hour ago, or about an hour ago, wind all of a sudden picked up, and it lasted about 20, maybe 30 minutes at the most, and then calmed right back down again. So I don't know how it's going to be for you in Las Vegas Valley, but out here we just had like 20 or 30 minutes of wind, which I just sort of, we just sort of grinned and bared it through that. But thankfully, it just backed right off again, and back to being pretty much calm and another beautiful astronomy night. We've just had a week of great nights, a few already, and a few more coming up, hopefully. But yeah, you should have some nice weather for it. It's pretty darn nice right now. Yeah, tulip. That's a nice one. That's a good one for your big fracks. Small, faint object that stands up well to filtration. When I'm doing narrowband, I sometimes go for that. Although it's a little small for me, because usually when I'm doing narrowband, I'm using the Canon camera lens. So, wide field. The tulip is a little small, but I can still see it. But yeah, filtration does well. Does real well with it. It's in such a thick star field. Hit 10-minute subs. Yeah, I was telling everybody about long sub exposures earlier and versus short. You definitely do the long ones. I've managed to get up to 5-minute exposures on a somewhat normal basis when I do my narrowband stuff when the moon is up, but other than that, I like to stick usually at around a minute or two. Otherwise, it's like watching paint dry. Nice. How cool. I look forward to seeing that image. Okay, there's 15 minutes on the Omega Nebula. So let's go. Up to the next one. All right. That's going to be right here, the Eagle. Center that up. And get this one started. Okay, the Eagle Nebula, or the 16th object in Charles Messier's catalog. It's a young open cluster of stars in the constellation Serpens, discovered by Jean-Philippe de Chazot in 1745-46. Both the Eagle and the Star Queen refer to visual impressions of the dark silhouette near the center of the nebula. So, I don't know, even though this looks like kind of the head and the wings of an eagle in flight, maybe, or some sort of raptor. What the name refers to actually is this little patch in here that looks like maybe an eagle with its wings spread, or a star queen. I don't know what the star queen is. But these actually are what have come to be known as the pillars of creation. And from the very famous Hubble Space Telescope image. And when we get a few subs in and the image cleans up a little bit, I'll zoom in and we'll take a look at that a little bit closer. But for now, this is where this little thing right in here is what given it its name of the Eagle Nebula. The nebula contains several active star-forming gas and dust regions, including the aforementioned pillars. The Eagle Nebula lies in the Sagittarius arm of the Milky Way. The Eagle Nebula is part of a large emission nebula or hydrogen beta region, which is cataloged as IC 4703. It's a region of active star formation and is a little under 6,000 light years away. The cluster associated with the nebula has approximately 8,100 stars. 8,100 stars. Yeah, that's right, Greg. Everything's running on an AM5. In fact, I have my... there. That's what I actually am using. My little 6-inch imaging newt on the AM5 on the spare no expense cinder block pier. Yeah, I've got the AM5. Gosh, it was January 23, so I've had it over a year and a half. And it's been a great mount. I love being able to carry 11 pounds in and out of the house. And, you know, which weighs, you know, a quarter what my AVX did. And gives me, you know, twice as good guiding. So, was worth the investment. Yeah, that's about right. I would have to just move it to the front of the pier, because the bolt head right there that the shaft can go on is right in there. But the reality is, I would probably never, mounted on this pier, I would probably never have to use a counterweight anyway. Strain wave mounts are really, really strong. So this mount has a weight limit up to, I think it's 25 pounds or something, where you don't need the counterweight, and then above that you do. And the reason they say that you need a counterweight over 25 pounds is not because the mount isn't strong enough, but because they're concerned that without a counterweight shaft and counterweights, if it's on a tripod or something, the whole thing will just tip over, it'll collapse. So they don't want you using more than 25 pounds, but the mount itself can handle a lot of weight. These are surprisingly mighty, strong little mounts, the strain wave gears. So I probably wouldn't even need up to 40 pounds or more. I probably still wouldn't need to put a counterweight, any counterweights on the thing. So yeah, I'll never, I didn't buy a shaft for it, and I probably never will, because I doubt I'll have anything that ever needs it anyhow. But yeah, these are cool mounts. answering Ray's question, he is actually in Las Vegas, Henderson specifically, which is why he said he was going to be shooting HA tonight, because he can pretty much only do really narrow band stuff and line filter imaging, because he's under Bortle 8 plus Bortle 9 skies. So, oh, there he is. He's answering himself. So. Well, that's 15 minutes on the Eagle Nebula, and I've been going for about 2.5 hours, and I got to be up early in the morning, so I think I'm going to call it a night. Thanks to Ray and Greg for stopping in. Greg, have a good night of shooting some data, and thanks to everyone else who has stopped by tonight. And it was great having you all here. Hope you got to see something that you enjoyed. It's been a pretty good night here, except for that brief period of wind, but it settled out nicely, so I got to have a full evening, which I'm very happy about. Like I said, the oh, hey Curtis, good to see you. Yeah, like I said, the weather is supposed to be nice for the next few days, possibly even through the weekend, so I may be setting up another one for later in the week or the weekend, so keep your eyes out and subscribe. Hit the subscribe if you're not already. If you're on my email list, well, then you're getting my emails whenever I do one. But yeah, I may see one. We may see one happen again later in the week if the weather holds. But right over the bed, yeah, yeah. You have to be pretty picky, all right. Anyway, good night, guys. Thanks for being here, and I will see you next time.